Okay, let's look at multiplying a radical expression that has a monomial and a polynomial. So if you look here, I have square root of 7y, which is a monomial. It's connected by multiplication. Inside my parentheses, I have square root of y minus 2 square roots of 7. So there's two terms here, which is a binomial. Now we know we cannot subtract these because these terms inside are not alike. I have a square root of y and a square root of 7, and those are not alike. We can't even make them alike. Y is in lowest terms, and 7 is prime, it's in lowest terms. So we can't do anything inside. So I know I'm always following order of operations, but again, we can't do what's inside. So our only goal is to drop these parentheses. We know in math parentheses means multiplication. So we want to multiply by square root of 7y. So we're going to use our distributive property. We're going to multiply square root of 7y times the square root of y. And everybody look, these are monomials, which means there's no work. It's right up here in your head. If you look outside our coefficients, 1 times 1 is 1. Do I need to write that? No. So these are the radicands. They're inside. So when I multiply them, it stays inside. So here's my square root symbol. 7y times y is 7y squared. Are we done multiplying? No, because we're not done distributing. Now we got to take our square root of 7y and multiply it to this term, negative 2 square roots of 7. Again, coefficients first. There's a 1 out here, and there's a negative 2 out here. 1 times negative 2 would be negative 2. Then we'll multiply the radicands, what's inside. Square root of 7y times square root of 7. So we'll put our square root symbol. 7y times 7 is 49y. Okay? So just like we did with polynomials, we distributed. Now the problem is you're not done. It says to subtract. Are these like terms? Well, no, they're not alike, even though they're square roots. This has a 7y squared as the radicand. This has a 49y. But you can't stop here because now you got to see, maybe I can make them alike. Let me see if I can simplify them, reduce them. If you look, I always have my perfect square and perfect cube list with me. Because in this whole chapter and module, anytime we're dealing with roots, we got to make sure they're simplified. So here I go. I have a square root of 7y squared. Can I square root 7? Well, 7's not a perfect square, and there's no perfect square. 4 and 9, none of those numbers divide into 7. So we're left with square root of 7. Can I square root y squared? Well, if a variable is a perfect square, it has an even exponent. So yes, I can square root this. What times itself is y squared? We all know that. The square root of y squared is y. Because we've done the operation square root on it, the y does not go back inside the symbol. It goes on the outside. So the square root of y squared is y. 2 divided by 2 is an exponent of 1. All right? Let's go to the next term. We're going to leave the minus 2 because it's not in a square root symbol. There's nothing we can do with it. We're square rooting 49y. So we start with the number. Can we square root 49? Well, 49 is a perfect square, so we know that answer. What times itself is 49? 7. So a 7 comes out. Now make sure you put it in parentheses because it's right next to that 2, which means it's connected by multiplication. Can we square root the letter y? No. Y has understood an exponent of 1. To square root, you must have an even exponent. 1 is the lowest exponent. That's positive. So you can't even reduce this or break it down. So because we can't square root y, it stays inside the symbol. We can't do the operation. So now let's simplify. This term is y square roots of 7 minus 2 times 7 is 14 square roots of y. Now can we subtract? Well, this term has a square root of 7. This term has a square root of y, which are reduced, but they're still not alike. So that's as far as you can go. Because we got these roots, these radicals in lowest terms, and they're still not alike. That's it. They're not alike. It's like having an x and a y. You can't add it. You can't subtract it. So I can't subtract these. So that would be my final answer. Okay, I know it's crazy. It looks a little bit ugly, but it's all these concepts you've already learned. I'm not really teaching you anything new here. I'm teaching you to apply what you know about multiplying. All right, we've got some more multiplying to talk about. See you in the next module.